In this video, we'll be looking at antiderivatives, or integration if you will. First, a question. What function has a derivative of 3x squared? If you answered all of the above, you would be correct. And another question. Which of these functions has a derivative of negative 3x to the negative 2? And again, all of the above. So, what function has a derivative of 4? Here you could answer y equals 4x. That would have a derivative of 4. Or you could answer y equal 4x minus 1. That also has a derivative of 4. Or, for that matter, you could answer y equals 4x plus any constant. Let's look at some vocabulary. What we've been looking at up to this point is differentiation. The verb is to differentiate, and when we differentiate, we are finding the derivative. So that's what we've been doing. Now the inverse, which is what we were looking at the 3 questions above, antidifferentiation, or finding the antiderivative, but more commonly used is integration, and the verb is to integrate, and you find the integral. So these are the new words that we'll be looking at now. The symbols that go with those. This little curvy thing is our integral symbol. This is the integrand. This is my variable of integration. And this is that arbitrary constant that we add on. And as you can tell from this equation, when you integrate the derivative, you get the function. So it's the inverse operation. So we can write that in 2 ways. Integral of the derivative with respect to x is the function in x plus some arbitrary constant. Or when you take the derivative of the integral of f of x with respect to x, you get f of x. So these these 2 statements are the inverse operations. So let's look at our power rule and then the inverse of the power rule. This is the power rule that we've been using up to this point. Whenever we have x raised to a power, to differentiate that, we multiply the exponent by the coefficient, so that comes out front here, and then we multiply that by x raised to the power decreased by 1. Right? So our inverse of the power rule, when we integrate, again we're going to start with x raised to a power, but here we subtracted 1 from the exponent. Here we're going to add 1 to the exponent. So we now have x to the n plus 1. And in this case, we multiplied by that original exponent. And here we're going to divide by the new exponent. So our rule, the inverse of the power rule then for integrating, is to add 1 to the exponent and write that x to the new exponent divided by the new exponent. And then always, always, always add your arbitrary constant on. So always add c. So let's start with f prime of x equal 15x squared. Now we know from our statements of inverse operations that when we integrate a derivative, we'll get our function. So what we want to do is integrate both sides. This one is going to be with respect to x, since our function is in x. So the integral of f prime of x is just going to be f of x. And 15x squared, we want to add 1 to the exponent. So we get 15x to the third power. And then divide by that new exponent. So divided by 3 plus our constant. Let's simplify this a little bit. So our f of x is equal to 5x cubed plus a constant. Let's box that in. And then usually it's pretty easy to differentiate this answer to check ourselves. In other words, if we differentiate here, we'll have f prime of x equals, and then using our power rule, we have 15x squared plus 0. So this is our check. We need to end up back where we started with when we integrate, and then check. Let's do another one. We want to evaluate the integral of 6x squared dx. Again, we want to take our 6x squared, but we want to increase our exponent by 1. So that'll make it an x cubed. So this will be 6x cubed. And then divide by the new exponent. So divided by 3. Don't forget plus a constant. Simplifying here, we get 2x cubed plus constant. Our check on this one is to do the power rule. 3 times 2 is 6x to the second power plus 0, which is 6x squared. That's what we started with. Let's do one more. We want to integrate negative 11x to the 6th power. So we're going to increase our exponent by 1. So that'll be a 7. And we have negative 11x to the 7th divided by 7 plus our constant. And this won't simplify any further, so box that in as our answer. Again, check yourself. 7 multiplied by a negative 11 sevenths is negative 11, and then to the 6th power, so negative 11x to the 6th plus 0 is our check. And that's what we started with.